So today we're talking about the difference of squares, which is a special case of factoring. And we just reviewed a problem like this. When we factor something that looks like x squared plus some number x plus another number, we're always looking for factors of c, this last number, that add up to b, where b is our coefficient on x. Okay. And a difference of squares is just a special case where b equals 0. So we don't really have an x term. If I have something like x squared minus 9, this is factorable. And what I'm going to do is I'm going to look for factors of negative 9 that add up to 0, because I could rewrite this like this, plus 0x minus 9. So factors of negative 9 that add up to 0.
3 and negative 3.
Yeah, and 3 and negative 3 jump right to mind. Let's just FOIL that out though to check to see if it really works. 3 times negative 3 is definitely negative 9. But let's see if we really get 0x in the middle. So we've got x plus 3 times x minus 3. So I'm going to do, however we do this, x squared. I definitely have my minus 9. And then I have 3x minus 3x. So what is 3x minus 3x? 0x. 0. X squared minus 9. So that really does work. Let's do one more example of this. Once you start to get the hang of it, these are really quick. Let's say we had x squared minus 100. Can you factor that? Okay, does 50 times 50 equal 100? 10 and 10 do though, right? Good, so x plus 10 and x minus 10. And you notice we're always going to have plus in one and minus in the other with a difference of squares. So that's one of the characteristics of a difference of squares. One factor has the plus and one factor has the minus. And then you're always going to have the same number, because the only things that are going to add up to 0 are positive and negative of the same number. So what else does that mean, Lisa?
That x squared minus 100 or x squared minus 9, it's always a perfect square. So
These work best when this number is a perfect square. And that's why we call it the difference of squares. Because we have a square here, a perfect square here, and a perfect square here.
Can it work without a perfect square or not?
So let's kind of look at why this works. So with a difference of squares, if we have a squared, oops, I don't need parentheses yet. If we have a squared minus b squared, that would factor, so factor a squared minus b squared, that would factor into a plus b, oops, not x, times a minus b. So I'm just taking the square root of the first one, a, square root of the second one, plus minus. Now normally, instead of b squared, we're just going to have a number, right? So like the examples we just did, this might be 9, But 9 is 3 squared. Or it might be 100, but 100 is 10 squared. So we had like x plus 10, x minus 10, x plus 3, x minus 3. And so sometimes you'll see the difference of squares written out like this. This is kind of like the generic case, but typically this is actually a number. So this might be 9 or 100 or 64 or 36, 4, 1. Right? It's usually going to be a perfect square. Now, before we go into what if it's not a perfect square, I just want to talk about one other thing. The a squared sometimes will also be more complicated than just like x squared. So for example, if I had 4x squared minus 36, is this a perfect square?
Yeah.
It is. Is this a perfect square?
Yeah.
It is. Do I have a difference?
Yeah.
So this is also a difference of squares, and I could factor it. Yeah. The square root of 4x squared is 2x, and the square root of 36 is 6. So I'd have 2x plus 6, 2x minus 6. So sometimes we'll have a coefficient here, and we still factor it the same way. I'm just looking for the square root of that one, 2x,
What if you had like
square root of that one.
3x squared minus
Okay.
36? Well, that's still.
Let me make sure this is still recording. Get this. Okay. So now, let's talk about the case where we don't have perfect squares. And this is really kind of probably a little bit beyond what you usually see in Algebra 1, actually. You just don't often see this. But let's say I had something like x squared minus 17. Can I factor that using the difference of squares?
No. Well, unless you do like a fraction or decimal.
So this is a perfect square, right? X squared. So the square root would be x. And I know I'd have x plus something, x minus something. Can you think of two things that multiply together that equal 17 that are the same?
No, but you could probably get one, like, if the x was like a negative, and then that plus,
It would be
oh,
like
no, never mind.
8 and a half.
No? Because 8.5 times 8.5 is like
Well,
70 or
oh, yeah.
something like that.
Well,
Let's think about it. What are we really looking for? We're looking for
the square
the square root of 17.
4.1231056.
We're looking for the square root of 17, right?
Oh.
So I could factor this. It doesn't factor into rational numbers.
Wait, so the square root is something valued?
Yeah, the square root of 17 is a number. So if I wanted to factor this, I would have to just say x plus the square root of 17, x minus the square root of 17.
Yeah, but the square root of 17 is actually like whatever's in the square root sign divided by 2.
No.
Or I don't know what it is.
So a square root is something that when you multiply it together, when you square it, it equals that original number, right? So the square root of 17 times the square root of 17 equals 17. Just like the square root of 4 times the square root of 4 equals 4, except I know that the square root of 4 is 2, because 2 times 2 equals 4. In this case, though, there is no rational number that I could multiply together times itself that I could square to get 17. So I just have to write the square root of 17. Or I could write a long decimal that I got from my calculator, right? 4.1 whatever it is. So yeah, technically I can factor this. And this is the only way to factor that. It's not like there are going to be other factors that are easier. But again, you don't usually see that very often. And then the last thing that I want to talk about is, what if I had this? X squared plus 16. Can you factor that?
Oh, it's not a 4 times 6.
It's
Yeah.
not a difference. But why is that important? Couldn't I just do 4 and 4? X
Why is that?
plus 4 and then,
Well, no,
That
because
doesn't
we have
equal
eight.
0.
yeah, because if I had x plus 4
Oh.
times x plus 4, I would have an 8x,
So did you
right?
write no solution?
But if I had x plus 4 times x minus 4, I would have a negative 16. And that's where the difference comes from. It has to be a difference in order to factor it.
So
So if someone ever asks you to factor something that looks like this, right, a sum of squares, you could say no solution. There's no way to factor that. Well, it's all, in math you can never really say like no way, but there's no way to factor that.
Are you crazy?
So let's just do a couple examples just to make sure we're getting this. What if I had
So it would have to.
16x squared minus 81? How could you factor that?
It's gonna be 4x plus 9, and then 4x minus 9.
That's it. Pretty quick, right? We just take the square root of this, so the square root of 16 is 4, the square root of x squared is x. The square root of this, which is 9, and we just say 4x plus 9, 4x minus 9.
So for it to work, it would have to either have to be like a negative x squared and a positive of the other number, or a positive x squared and a negative.
Okay, n squared minus 1. Can you factor that? Uh-huh.
Wouldn't it be parentheses n plus the square root of 1?
What is the square root of 1? 1.
So it's just plus 1 and minus 1 because 1 times 1 plus 1.
Right.
So you can multiply by as much as you like.
So n plus 1 and minus 1 is the factored form of n squared minus 1. What if we had something a little different, like 36 minus x squared?
Could you use commutative property and turn it into negative x squared plus 36?
I could, but then I would have a sum of squares.
How?
Because it would be
Because it'd be
plus,
adding.
so it wouldn't be a difference.
So this thing is a little bit weird,
Oh, it would be.
but it actually still is a difference of squares, remember?
Yeah. it
All I'm
doesn't
doing is
matter.
taking the square root of this and the square root of this. So what's the square root of 36? 6. What's the square root of this?
X.
Minus
X.
x.
And then the same thing again with a minus. So I can do it if they're switched around as long as there's still a minus. 6 plus x, 6 minus x. And again, this is not something you see very often, but it's good just to look at, like, what does this allow us to do? And it does allow us to factor this as well as this, as well as this. Yeah.
It doesn't, like in other versions of this, like, but like doesn't really matter if it's like negative 9 and 9 or like 9 and negative 9, like it doesn't matter which order the.
Doesn't matter which order, right? Yeah, you can write your two factors in any order. N plus 7, n minus 7 is the same thing as n minus 7. So it doesn't matter if you write the plus or the minus first. A lot of us will get into a habit of which one we write first, which is fine. There's not really a correct answer to that though. Either one is fine. Okay, so there's one other step to this. One last example of a difference of squares, which is if I have something like this. 5x squared minus 20. Is this a perfect square?
No.
Is this a perfect square?
No.
So I could use
Oh,
square
we
roots. I could say like the square root of 5 times x plus the square root of 20. But there's actually a better way of factoring this.
So since 5 goes into 20, would you do something like, what is it, 4?
Divide by 5.
Yeah, there's a 5 in here and in here. Now I can't really divide because I don't have an equation, but the first thing that you always want to look for when factoring is to see if there's a greatest common factor and just factor it out. So what we've noticed is there's a 5 here. So I'm going to just write it out front, and then I'm going to rewrite this over here. So my factors, right, are going to include 5. 5 will be one of my factors, but I'm going to factor this kind of separately. So I factor out that greatest common factor. And now I can factor this. X squared minus 4 just factors to, let's see, square root of x squared is x, square root of 4 is 2, so I have x plus 2, x minus 2. So if you see like a greatest common factor in there, just pull it out to the front. Now if this said, which will often happen later, if this said equals 0, I could just divide everything by 5. I could divide this side of the equation by 5. 0 divided by 5 is still 0. So I could kind of get rid of the 5. That's only if it equals 0 though. I can't divide if I don't have an equals. I have to just factor. So I'm simplifying. So I think there's maybe one problem on your homework like this, where you're going to have to factor out a greatest common factor first. And then what you'll end up with is a couple of perfect squares that easily do this little difference of squares matter. Alright, I'm going to turn this off. You guys have questions?